Today, we will be talking about sustainability, climate change, and degrowth. And it is Professor Jo van Biesebroek who will be leading this presentation. Professor van Biesebroek teaches at the Catholic University of Louvain, and he is an academic scholar leading in the field of economics. He also gives advice to international institutions, to governments, and that includes the European Union and the Belgian government. As always, we thank you for being with us and encourage you to subscribe to our channel if you haven't done so yet. And in any case, without further delays, let us begin.
This is it. All right, so let's start with this. It's going to be a lot about climate change. So we first have to ask the question, is our climate really warming? Less so in Belgium, but in America, it's an extremely loaded political question. I feel you can't even ask the question because I think people lost all perspective when they think about this. And so that's maybe my first message. I really think we want to remain critical because so when Philip Morris, who owns Marlboro, when they sponsored lots of research on secondhand smoke, nobody believed them because this was crazy. This was a tobacco company earning money from smoking. If they're saying smoking is bad, of course we're not going to believe them. But now we have this situation where the entire climate research is become a gigantic enterprise. And then all of these scientists think that climate is horrible, and we believe them. While their entire lab and their entire livelihood is wrapped into climate being the worst thing possible. And I feel we lost a little bit of our necessary skepticism. And when you look at things, there's very worrying things. So for example, the main data set that they use to know the evolution of climate is this AR4, which is also called the tree ring database, which spans back 1 to 2,000 years. When the rings of a tree are very broadly spaced apart, it means it was pretty warm, and they get temperatures from there. But sometimes stuff happens, they need adjustments, but all the adjustments in the database, they're all raising global warming. While this should be random, like half of it should be raising and half should be lowering it, but all the adjustments the scientists make, they all make global warming seem worse, right? So this is the main data set going back a bit over 1,000 years. And so there's problems with that, but it's all we have, so we need to rely on it. We can also just measure temperature. So we've had measuring stations all over the world. But the problem is, so maybe there was a station in Waterloo, I don't know. In Uccle, for example, there was one. And Uccle was 4 kilometers outside of Brussels center. It was farmland. There was nothing. You put a temperature station there, you measure it, and that's great. But now we are 60 years later, and now Uccle is in the middle of the Brussels agglomeration. The entire community is full of pavement and asphalt. And on a nice sunny day, everything heats up. And at night, when they measure this temperature, just the heat radiates and the temperature's off the scale. And then the scientists come along and they say, man, global warming is terrible. It's not terrible. We just built a parking lot around the measuring station. And if we had known, we should have put the measuring station not in Uccle. We should have put it maybe somewhere in the middle of the Ardennes. And then we'd have a very nice time series. But we can't go back. It's the only thing we have. And so again, that's the second thing that is really inflating how bad climate seems to be. Right. So those are two things which I think are very important. Right. And so here I want to show something. So this is the United Nations International Panel on Climate Change. There's a main organization alerting us to the dangers. It's more or less the consensus of the scientists working in this area. They're always very worried about climate change, but at the same time, they're also scientists, so sometimes they also want to be a bit objective. And so when they were preparing their 2013 report, I saw the graphs initially, which looked even a lot worse than what eventually made up in their report. But this is what got published. And so there's lots of details on it. But the only thing I want to point out is that, so this is the timeline. This is measuring the deviation. So basically, in the 1950s, we normalized this. That's kind of 0. That's the base temperature. And then these lines are like the observed temperatures, and they're going up. So warming seems to be happening. But all the other lines is basically the scientists building models. And the thing is, this warming happens very gradually. Like the change here is kind of, it's like decimals of a degree. So it's very hard to detect. So we have lots of models trying to predict how bad climate is going to be. And that's all of those lines. But so what happened is, when they were preparing their 2013 report, all the measures were here and all the predictions were there. So the actual temperature measures were lower than the most conservative models that they could come up with. Every single model that the climate research community worked with predicted way more warming, because we can observe how much CO2 emissions there have been, how many other greenhouse gases there have been. We can predict how much warming should we expect, and those are these lines. But the reality was, warming had stopped. And at this point, we had about 7-8 years where there was no warming at all. That's kind of amazing. And then you read the report, and the report is all about how horrible climate change is, and that we need to stop it, and we need to do something about it. But that's the data. And the data did not show any warming. So we got this huge disconnect. If you look in the scientific literature around 2013, all the scientific literature was about, where on earth did all the heat go? We emitted so much CO2 in the last decades. We all expect this, and that's not what we're seeing. But then the advocacy for climate change things, they did something very different. Right? So that's why I say, let's try to remain critical, okay? And don't believe everything we hear right away. We want to be skeptical. And so these are 3 areas where I, as a scientist, I'm extremely skeptical of other scientists. When you ask my macro colleagues what's the worst thing around, they will say inflation is the worst thing around and we need to stop it. When I ask my psychology colleagues what's the worst thing around, they say depression and burnout at work. Everybody thinks their field is the most important thing around. And the climate people, naturally, they feel that global warming is the worst thing around. And I think it's even, we need to be critical because we also need to make decisions. And so one decision we need to do is, once in a while we go on holiday and we need to decide, how should we go? Should we take the bus? Should we take the car? Should we fly a plane? And clearly, if you've been paying attention and reading the newspaper, of course, you're not flying because flying is horrible and public transport is great. So we all should take the bus. All right. And then it doesn't take you very long. So these numbers I'm going to show you are kind of approximate, but a little bit of research on Wikipedia gives you, for a city bus, a fuel consumption of 6.5 liters per 100 passenger kilometer, which is not very good. For a car, the average car in the EU nowadays, you get 3.5. It's a bit better than most of our cars get, but the average car runs with 1.5 person in it. And so per passenger kilometers, we divide the actual fuel efficiency by 1.5. Again here. And a plane is this, and there's a range. So Wizz Air, I'm not sure whether you've flown it from Hungary, they're the best one in Europe. They're at 2.5. And Lufthansa is one of the worst. They're at 3.5. But the plane is the best of the 3. That's crazy. Now you read the newspaper, you would get executed for taking the plane. Well, this is just like 10 minutes research on Wikipedia gives you this. And that's not what we expect. Well, the reason, of course, is that these buses, they're all empty. Like the average capacity utilization of a bus in the EU is 8%. look around, all these buses. There's one bus in the morning bringing the school kids to school. That bus is full, and all the others are empty. And that's why this fuel consumption per passenger kilometer is so high, because the bus is empty. While have you flown with Ryanair? Well, they're pretty full, and yeah, that's good for fuel consumption. Right? And so when we're picking what to do, clearly the message is you shouldn't go anywhere. You should stay home, because the plane, of course, it has very low fuel consumption. Yeah, but if you're flying to South Africa and you're flying 10,000 kilometers, that's still a lot of fuel, okay? And so clearly we don't want to compare apples with oranges, but the last thing we want to do is put more buses on the road, because they're all driving around empty. During Corona, the Flemish government did not cut down on any frequency of buses. Capacity utilization dropped to 3% in Flanders. And the emissions per person just went through the roof. And so putting more buses on the road, the existing buses go empty. So putting more buses on the road is double great. Right. So we have to keep skeptical. All right, so that's my beginning. So now let's turn back to climate change. So before the room empties that I'm one of these climate deniers, the good news is climate change is real. So if you were worried about it, you're right to be worried, because the climate is warming. The last 5 years have been really warm. We've broken all records there is. Maybe not as bad as you sometimes read. I would say the most reliable sources are these atmospheric measures, where you just measure them up 50 kilometers in space. And by then we already are at 0.3, 0.4 degrees warming. So staying within 1.5 degrees temperature rise by the end of the century is going to be very tricky. And so all of my start of we should be skeptical, and I still think we should be skeptical and we should be critical, but at the same time we have to be open to evidence, and the evidence the last couple of years about warming has been really bad. We're almost sure that man-made emissions is a primary reason, and so at least we're right to be worried. All right. Okay, then the next question is, what should we do? I'm already getting warm from climate. So what we should do, so I'm an economist, so let's do some economics. It's more finance and economics, but I'm not sure whether you learn it in class, but I think you should. This is the simplest rule in finance. We are making an investment only if the net present value of the flow of benefits is higher than the investment. Oh, I was going to rewrite it. So this is a summation sign. So that basically means it's the sum of where you replace the k with a 0, and then plus the same thing with the k, you replace it by 1, and so on. Sorry about that. I was going to write it out. But so the idea is we're looking at the benefits in the future, and we're summing them up over the next infinite number of years. But benefits that we accrue very far in the future are worth less than benefits we get tomorrow. We know this from our bank account. We rather have money now than in 10 years, because if money now, we can invest it, and in 10 years, we have a lot more money. And so in order to compare money in the future with today, we need some discount factor to bring it back down to today, right? And so this is basically the sum of all of these benefits. So we're investing to tackling climate change. We're looking at all the future benefits, we compare it to investments, and then we make up our mind, is this a good project or not? But the problem is we now need this data. We need to figure out these future benefits. How much are we going to discount them when we bring them back to today? And here the problem is when firms do this every day, but firms, they maybe look 5 years out and things are risky, they might go bankrupt. So in the low interest rate environment from the last couple of years, like about a 10% discount factor would be a normal thing for firms to do. It would basically, the equivalent is more or less that an investment needs to give me a 10% return per year to be worthwhile. And so that's equivalent of using a beta, a discount factor of 0.9, right? So that means that all these future benefits, you multiply them by 0.9 to the factor k. If this is 10 years out, you multiply it by 0.9 to the 10th power, right? And here I showed you in the table what that means. It means a benefit 10 years from now, you only value this at about 35% of the real value. A benefit 27 years from now, 27, that's anything happening in 2050, you only count it at 6%, and everything later you just ignore. So anything that benefits us 77 years from now, you should just ignore. Right? That's what this says. But that's only the case if we're using this discount factor that firms do, and firms face a risky environment. So when we are a government and we're making government decisions where we're taking everybody's benefits into account, we probably want to care also about the kids that still need to get born, and we probably want to use a lower discount factor. So very often for government projects, they would use 5%. So then the beta is 0.95. And when you take these powers, it doesn't decline as quickly. So you see these numbers are a bit higher, but still anything that benefits us 77 years from now, we can divide by 50 in order to see what's the value, how much we want to invest to get the benefit, right? And so that was basically on Monday, we're learning the new Nobel Prize in economics. 5-6 years ago, the Nobel Prize in economics was given to environmental economists, and they basically said that this entire climate change business should all be about the discount factor. We have to figure out what's the right thing to use. And some people say is that, well, we shouldn't discount this because this is infinity. We need to preserve the world for our kids and our grandchildren and the kids of our grandchildren. We need to value their life just as much as our lives. So if we get a benefit of €1 1,000 years from now, that is still €1, and we should count it as €1. But that doesn't work because this is an infinite sum. If you think like that, then we should spend all of our money to fight climate, and we should all starve. So we need some discount factor to trade off the future with today. And so I think the Stern report in the UK, they suggested just totally randomly ad hoc, let's use 1%, and then basically benefits far out, you divide by half, more or less. So because this is an infinite sum, this would really increase the impetus to invest a lot. And so I think that's one of the most important things in the climate debate that nobody is talking about. And it should all be about that. So when economists write reports on this, the conclusions are always totally driven by the choice of the discount factor. How do we compare benefits 100 years from now with costs that we're incurring today? And it's an unsettled business. And 0% is crazy, but 10% means you're ignoring the future. That's also crazy. And we don't really know what to do. All right, so that was economics. Okay, so something related is, so maybe we're looking here, how much should we invest? But we can also think, when should we invest? Because we're getting richer now. So this shows you, like I just took some random graph from the internet over the last almost 200 years. This is BNP per capita, GDP per capita for the United States. I put it in a log scale so that percentage growth shows up as a linear line. And so what we're seeing from 1809 to 2009, so for 200 years, the GDP per capita is more or less following this exact line. So we got kind of the Civil War in America, we see the Big Depression, and then the rebound after the Second World War. But really how linear this is over 200 years. So that from that we learned that for the last 200 years, we have been getting richer at about 2% per year. Right? So that's ballpark on average, and Belgium and the UK is kind of similar as America. We're getting about 2% richer per year. All right. And now we go back to this compounding thing, because our economy is 2% larger tomorrow, and then it's 2% of that 2% larger economy. So that compounds over time. So that means that by 2050, we're going to be, we take 1.02 to the power of 27, we're 70% richer in 2050. If we think about 2100, so most of these climate predictions say, what will the world look like in 2100? We are 359% richer by that. And so, yes, I agree, global warming is a very important thing, and we should do something about it. But should we do it, or should our children, grandchildren do it, because they're going to be 4 times richer than we are? And so it's kind of crazy now. If we're thinking, we said, wait a minute, we now have to fix the climate, but it's really our grandparents that should have done it. But our grandparents, they were also like a quarter of living standards for us. They were really poor people. They shouldn't have done it. We should have done it. But you can keep saying this, and it's really our children that should do it. And so I'm just saying this, that we're getting richer, and anything we're doing now to screw up growth and screw up the normal functioning and growing of the economy is going to make us less rich over time, and it's going to make it a lot harder to tackle global warming. Right? And so get ballpark. So current estimates of, and that's from the United Nations panel again, the future cost of climate change is estimated at 5 to 10% of GDP in 2100. Right? So the idea is that 77 years from now, because of climate, we're going to be 10% poor. Right? But if we're growing at 2% per year, we're going to be 360% poor. Stop that. You should subtract 10% of this, and so we're only going to be 320% poor. And so that's what we're saying. We should really invest in stopping climate change, because otherwise our children's grandchildren are only going to be 300% richer than us. And we want them to be 360% richer than us. Well, if that's really how you feel, then you should definitely do that. But it's a weird statement to make. All right, so this compounding thing. So I'm very worried, in our zeal to combat climate change, we might screw up growth, and maybe our kids are not going to be much richer. They won't have climate change, but they're going to be as poor as we are. All right, and then, wow, that didn't come out well. So on the computer, this is a map of the world. This is so the punchline is that, of course, climate is happening at different speeds everywhere, and warming is by far the fastest at the poles. But there's nobody living there. And so it's not really doing that much harm, except for messing up our entire climate system. But then here is where people live around the equator. And so in terms of economic damage and human suffering, it's really around the equator where we're going to expect most damage. And so Brazil is also light red, but the projection doesn't come out very nicely. But it's not counterintuitive. India and Africa, that's really where the harm is going to be. While the north here is all green. All of these economies are going to be better because of climate change. We already noticed in Belgium, the Belgian wine industry is booming because all of a sudden we can grow wine. And there's several countries that will do better. And so one thing that we realized is, the future cost of climate change is vastly different if we are trapping all of Africans in Africa, or if we tell them, you know what, you can migrate to Siberia, there's lots of space there, agriculture is booming in Siberia, and you can go work and live there. maybe that's a bit far-fetched, but it's only far-fetched if we make it like that. And so we can calculate what's the future cost of climate, keeping everybody in their country. And then the cost of climate is really very damaging, especially here, misery for all these people. If you allow people to migrate, it is an order of magnitude more manageable, right? And that's, of course, it's a very politically difficult discussion, but again, a discussion that we're not having. How about migration? Okay, so something maybe a throw off is not that important, and I feel already going over time, so I should speed up a bit. You read in a newspaper, all these extreme weathers, we need to invest in subsidies for electric vehicles. But the problem is our warming is a function of what happened in the past. If we emit less now, the benefits are going to be felt 150 years from now. If you're worried about California wildfires now, batteries are not going to help this. We need to do something now. And the only thing that would work is really geoengineering things, but that's not really talked about. But that's my next one. So geoengineering is very unpopular. The IPCC in their reports, they don't really like this thing. And I agree, it's very risky. We can emit less, but we can also see what can we do to make our emissions less damaging or to take emissions out of the atmosphere. And again, it's something that is hardly debated. So one of the cheapest and easiest geoengineering projects would be stratospheric aerosol injections. You just take sulfur particles and you put a plane, you fly it up in the atmosphere, and they reflect sunlight. That really sounds very scary. We're really going to mess up the world if we're doing stuff like that. And that's kind of the easiest, cheapest thing to do to stop warming. So the IPCC does not like it. But guess what? That's exactly what we have been doing. In 2020, we banned sulfur from all maritime fuels. All ships used to have very dirty, sulfur-rich fuel. In 2020, we're saying that's not allowed anymore. And it was a great success. We emitted way less atmospheric sulfur oxide than we did before. And this is pretty bad for so sulfur where we live and where we breathe the air. That's not a good idea. And so the idea that we're burning less of that is really good for our environment and our health. But of course, we now have less sulfur particles in the air. We don't reflect the sun. And guess what? We are having global warming problems. So a big part of this increase in global temperature in the last 5 years, we did it. So at one time, we're subsidizing electric vehicles to lower our emissions. But then on the other hand, we're banning sulfur from fuel, which raises the temperatures. And so this is geoengineering that we're doing, but we're doing it in the wrong direction. We're making global warming worse. Right? And so again, like geoengineering is kind of dangerous and we need to be careful about it, but we're doing it anyway. And so we cannot ignore it. All right. So what else can we do? So if I think about what should we do about emissions as an economist, the simplest thing would just be to have a carbon tax. My next slide, just do an efficient debate and do a carbon tax. But this is a graph from the OECD where the length of the graph is basically all of the sectors in the economy, how much CO2 emissions they're responsible for. So road transportation is in OECD countries responsible for, what is this, about 15 to 20% of the total, right? And road transportation pays lots of taxes, explicit taxes at the pump, and also vehicle regulations. So the OECD calculates that they pay the equivalent of 80 to 90 euros per ton of CO2. And the rest of the economy, who does all of this emissions, they pay virtually nothing. Like a little bit here and there. We now have an emission trading system to tackle the electricity industry, but we first give them the emission rights, and at the margin they might save a little bit, but because they get the rights to begin with, overall it's not really an extra burden. And so when you see here, there's only one sector in the entire economy that is really facing any CO2 tax, and that's road transportation. And when you open up the newspaper, the only thing we talk about is regulating vehicles even more, raising fuel taxes even more, imposing fuel economy restrictions even more, and we're raising this from 80 euros per ton to 160 euros per ton. But house heating, which is about as important as road transport, you pay 0 CO2 tax. That's crazy. But again, it's what we do if we're uncritically we see a car and it's dirty and we want to do something about it, but we close our eyes for everything else that's dirty. Right? So that's very inefficient. All right. What is efficient? A carbon tax. You basically say anybody that emits fuel pays the same tax. I don't care whether it is to drive a car, heat your house, run a chemical business in the port of Antwerp. We don't care. Same emission, same tax. Very simple, but remarkably unpopular. So in France, Sarkozy launched this he thought this was going to be an election winner. He launched this, and in 2 days he had to retract everything from the carbon tax. It's really surprising because it's so simple, it's so efficient. It's not the best, maybe this emission trading system is even better, but it gets close to optimal, and it is unbelievably unpopular. Right. So what is popular is picking one specific technology, and we know that's terrible. So now the big thing is batteries, but batteries are an inefficient way of storing energy. The density of energy in a battery is way less than in fuel. So it's already obvious that it's much more efficient to use wind energy, not to charge a battery. You use wind energy to make hydrogen, and then hydrogen you can burn in a regular engine, and it's equally green as a battery, but it's a lot more efficient in terms of energy density. But the governments have decided we're going to subsidize batteries, and so we all have battery cars. So that seems a very risky strategy. All right. So I'm already over time. I had a couple more things to say. So yeah, I say one thing before I close off, that before I worked at the University of Toronto, and you might have heard of Naomi Klein. She hates business, and the year I arrived, the students had given her a prize, and I was teaching that day, and I had to introduce her. I was new to Canada, I didn't know her, and so I introduced her, and we met and we talked, and then afterwards I read her book, and my eyes went open because I said, wow, she has a very view of the world than I do, and I hated it, but the students loved it. And now I'm in Leuven, and we had the exact same thing. Kate Raworth from, I think she's at Cambridge. She got an honorary doctorate from the university. And I'm chair of the economics department, and I wrote a letter to the president. That's unbelievable. The book is horrible. One of my colleagues reviewed it when it came out, like a 6-page article, and he's like the most environmental, social person that I know of, and he hated the book. And but then the president says, yeah, but you have no say in this. She didn't get the scientific honorary doctorate. She was the candidate from the students. And then this, I just turned 50, and one of my friends, I think it's a joke that they're playing on me, gave me this book, knowing that I would hate it. But I don't want to throw things away, so I had to read it, and I do hate it, so it was right. But the thing I put it on here is that I feel we're failing our students, that when they do surveys on which students at the university are most environmentally minded, and so the second and third most environmental students are the bioengineers and the biologists, which makes sense because that's the field that they've chosen to work in. But systematically, the most environmentally conscious people in universities are economics and business students, because this is about efficiency. We're not wasting things. If you use a lot of fuel, it's bad for the environment, but it's also bad for the bottom line. I think being like the circular economy and sustainable, it's inherently an idea that economists can get by, but we don't teach it in our classes. Like if you saw my slide before with these mathematical formulas, it's a bit dry. That's what economics is like. And our students, they feeling they're missing something. And I think they're right. And so now we're trying to change our curriculum a little bit to talk more about these things. How can we bring an economic perspective in those things? Because I think these authors, they would benefit a lot from learning a bit more economics, but we're not connecting with them, right? And so they have important things to say. And I think we could have a very useful conversation, but it's not happening. Right? So I've been reading the books, but I guess that's not enough. I should also do something with it. All right, so maybe I leave it at that. Is there anything super important I wanted to say? You can go on. Yes. Okay, maybe a couple of minutes. So when I think about sustainability and degrowth and all of that, I don't really think economics is a bottleneck. And the reason I think economics is not a problem, those are the big problems. But I think this convinces me that economics is not a problem. If we're thinking about pension reform, if we're thinking about the big problems we're having in society, I think pension reform is one of the easiest things we can think of, no? What is a pension? I earn money, I set money aside for my pension, I work for 40 years, and then the money accumulated and I use it to consume when I'm retired. That is super simple. Now, I live longer. And so I need more money because I'm going to be retired not for 15 years, I'm going to be retired for 25 years. So I need more money. So what can we do? We can increase taxes, set more aside, maybe. We can work longer, not till 65, till 68. Or we can lower pensions, just spread it out. And that's it, no? It's not rocket science. You take some money, you put it away, you consume later. If you're living longer, well, you put more aside, you work longer, or you consume less. That's it. And we can even tell them, as a government, we don't even need to tell the people that. We just give them a menu. And you say, everybody, retire whenever you want. And the earlier you retire, the less pension you get. And if you want to add to your pension by saving more, sure. Pension plan, and you do it. This is the easiest thing on the planet, and not a single country manages to reform it. And so I guess that's the idea, that economics is not a problem. It's really politics and the way we do democracy. That's we just don't manage to come to an agreement. Like, there's no economics department where we have debates about pension reform. That is just too simple. I can explain it in my first year introduction class. I did it here in 3 minutes. In the first year, maybe I take 15 minutes with this is too simple to even talk about, but as a society, we don't manage to reform it. So I think we have a democratic problem more than an economic problem. Right. So that my first concern is our and this is tied to, I worked a lot on China, and they have a very different democracy. People would always get very mad when I call it democracy, but the Chinese, they're convinced that they also have a democracy, a different one than our, and I agree, some things are a lot worse than in our democracy, but some things are also a lot better than in our democracy. And so that was my other talk about. So that's one. When I think about sustainability, I think about John Maynard Keynes, the founder of modern macroeconomics. Before he wrote his famous macro textbook, he wrote an essay, The Economic Possibilities for Our Grandchildren. And so he made this prediction in 100 years, so written in 1930, so we have 7 more years to go. People will work for only 15 hours per week. He was convinced about that. Well, that did not work out. So this is 1990. So he writes his book at this point, and that's the number of hours people were working in the US, the UK, Belgium, and Germany. And so he looks at the line and he says, well, the future is looking great. We're going to end up at about 750 hours a year. That should be enough. But what happens is it goes on maybe for another 10 years, and then it just flatlines. Especially in the United States, hours worked has not gone down for 45 years. And this is the average for the economy. If you are an educated person in America, a manager with responsibilities, this thing is going up big time. Right? And you saw it in South Korea when they started getting richer. Everybody started working harder because they saw, wow, all my effort is really getting me some return. Same thing in China. And so the prediction was robots are going to do the work for us. And we're going to be so productive that we will all have a TV and a fridge and a car, and we can get by with 15 hours. And that's not what we did. We wanted 2 cars and 3 fridges, and we keep working hard and hard. Right? So that was unexpected. Right? And you would think the difference, United States and Europe, is very large. There is a difference. In Europe, we work a little bit less, but it's not hugely different. And so at the same time, while this is happening, the one thing that nobody saw happening during the Great Recession is when labor economists study the labor market, they have this thing which they call prime-aged males, because prime-aged males, they all work. Labor supply of 95%, so you can study what's the return to wages and schooling and all of that stuff without having to worry about the decision, should you work or not. If you have women in the sample, at least before, they would make a choice to work or not, and that complicates the analysis. Prime-aged males, it's easy, they all work. 95%, and 5% are unemployed or sick, or they just moved, and then that's over right away. But that was before, and so this, you can't see it, but this starts in the 70s, and it goes till now. And you see in the 70s and 80s, this is 90%, so this is about 95%, and then it started going down. And so now we're at 80%. So this is unprecedented in history, that prime-aged males, only 80% is working. And I don't see the Great Recession from 2009 on the graph, and I also don't really see Corona on the graph. It's just happening, and it's a process. It's very erratic, so it goes up and down with the business cycle. But over the last 20, 30 years, you have 20% of the American population, prime-age males, who's not working. Never happened before. And so if you're not working, you just disappear from society, the way we've organized society. And so in that sense, that's a bit worrying. And this happens. I didn't put the slide on it because I didn't find a nice graph. But burnouts across the economy are getting a bigger and bigger problem in the entire workforce. So those two things are happening at the same time. Like a fraction of the population that has always been working is now in massive numbers stopping to work, while another fraction is kind of taking up all the slack, but also all the wages. We got wage inequality, but you need to work hard for all that money, and people get these burnouts, and we get this huge divergence in society. And then something else, we have fewer and fewer kids. This is showing us fertility. The amazing thing is, I'm not sure whether you paid attention, but last year, even India fell below replacement. So even India is now having fewer kids than necessary to keep the population stable. So it's only a matter of time before also India is starting to shrink. The only place in the world where we still, as a human race, have more kids than necessary to keep our population stable is in Africa. This is Nigeria. They're at about, 5.5 kids per woman, even today. But Africa is the only continent that's not going to shrink. All the others are shrinking. And if you think about sustainability, that should be good. If we think about dividing up the work and going to 15-hour work week, that should be good. But that's not what we did. What we did is we have not reformed pensions, and now our governments have these unfunded pension liabilities, and during the last recession and Corona, we amassed this unbelievably large government debt, and all of a sudden, having low population growth is bad. Is our society going to be sustainable? So this should be good for sustainability, but it's really bad for funding all of our debt and liabilities. So that's my big sustainability work. All right, I think that's it. Yep. So sorry to go over time.